Hello, this is Captain Chaudhari in my series of videos on basic ship stability calculations. Today I am going to do end compartment bilging. Our subject is box vessel, right? And this is a box vessel, 100 meter long, 20 meters in breadth. It has a kg of 5.2 meters. It floats on an even keel draft of 5 meters. Now there is an end compartment, let us say it is a forward end compartment, 10 meters in length. It has got cargo of permeability, homogeneous cargo of permeability 70%, and we want to find out if this compartment is bilged, what is the final draft going to be, right? So we will start. The initial steps are same as midship compartment bilging. First, let us draw the vessel. Here is box vessel 100 meters in length. At the forward end you have 10 meters and craft floats at an even keel draft of 5 meters. Permeability here is 70% and this compartment is bilged. So the lost buoyancy will be 10 into 20, that is the breadth of the vessel, multiplied by 5 into 0.7. So we maintain the rule that lost buoyancy is found till initial water level. So 10, the lost buoyancy is 700 meter cube. Now intact water plane area is total minus lost. So that is 100 into 20 minus 10 into 20. Loss is to be always multiplied with permeability. Permeability goes with the loss. And we always find out the present value as total minus lost. So that becomes 2000 minus, you have 140. That gives me 1860. Okay, now we will assume that the vessel initially sinks bodily, and thereafter what happens is the vessel goes on a new draft like this. Initially the center of flotation was here. The center of flotation would go away from the damage on a new water line. So this is how the center of flotation shifts. Okay, so the sinkage, the initial sinkage can be found out as lost buoyancy divided by intact water plane area, that is 700 divided by 1860. Gives the sinkage as 0.376. Right, so the new draft can be 5.376 meters. This is what we have found out in the same fashion as we used to find out in case of a midship compartment damage. Now one of the first things that should be done for an end compartment, I will write down the new draft as, so I'll salient data I will write down as lost buoyancy is equal to 700 meter cube, intact water plane area as 1860, and new draft as 5.376 meters. Now one of the first things that should be done in case of an end compartment bilging, or if it is not a midship bilging, that means an intermediate bilging, is look at the ship in a plan view and show how the center of flotation would shift. Now to find out how much will the center of flotation shift in a direction different than the damage. If the damage has occurred here, the center of flotation naturally should shift on the other side. So we need to find out what is the shift of center of flotation, or what is FF1. So what we do is we take the moment of area, right, And to reduce the calculations, what we do is we take the moment of the entire area, regardless of damage, the entire area about own midships. So when I take the moment of total area about own midships, the idea is like to eliminate one particular component. If I take the moment about own midships, the moment will be zero naturally, because the distance from centroid to centroid is zero. When I take the moment of area, I must take the distance as centroid of the area to a reference line. But that reference line is the centroid itself. So distance is zero. So always in end compartment bilging, whenever we are finding out FF1, we start like this, taking the moment about own midship. So the first component is always zero. Minus, what is this area? This area is 10 into 20. And what is the distance to the original centroid? Now half the distance is 50 meters, we know. And now from here to here is 5 meters. So this distance should be 45 meters. But mind you, this is loss. Loss is to be always multiplied with permeability. Divide by intact water plane area. And intact water plane area is 1860. So let's do this calculation. 0 gets cancelled here. So we have 20 into 45 into 0.7 equals, divided by 186. That gives me 3.387. This is 3.387. So this distance is 3.387 meters. So as I said, in end compartment bilging, one of the first things that we do is find out the new position of center of flotation, because remember, we want to find out what are the new drafts. That means we want to know how the vessel pivots about an athwartship axis. So earlier the pitching or change of trim used to happen with respect to an athwartship axis passing through the center of flotation. But now the new center of flotation is in a different position. So that would be deciding the athwartship axis for change of drafts forward and aft. Right. So what I've got is FF1. Now this particular damage that you see is a damage that is uniform vertically. So I had told you in my previous lectures, whenever it is a box vessel and damage is vertically uniform, we can always say that KB is half of the draft. So we can say that KB is half of 5.376 and half of that is 2.688. 2.688 meters is a KB. Now the question is, in the question, actually it is not required as to what is the GM transfers. What is required in this question is what are the final forward and aft draft. So what we do is basically we concentrate on finding out BML or GML, right? So how to find out the BML? Like BM transverse is related to the rolling. Similarly, BM longitudinal is related to pitching. A short explanation would be like this. Basically, if we consider G to be here, then this distance is GML, and if center of buoyancy is over here, right, this distance is BML. Now there is a shift of center of buoyancy. There is a shift of center of buoyancy. The way center of flotation has shifted, center of buoyancy also shifts away from the damage. It goes to a new place called B1. And this causes a change of trim. and suppose we say this is the new water level, and the vessel trims this way because the damage is over here. The vessel trims this way. Naturally, wherever there is damage, the vessel will sink that way. So there is a trim change forward, there is a trim change aft. Let us say the TRA, that is the trim change aft, and TRF, that is the trim change forward. The total is TRC. So we say TRC is equal to TRA plus TRF. Mind you, TRA and TRF is the change of draft aft and forward respectively because of trim change alone. So this trim change upon LBP, LBP is the distance from here to here. So if we say total trim change, that means this component plus this component divided by LBP should be equal to GG1 upon GML. But in this particular case, we are talking about shift of center of buoyancy, and to maintain equilibrium, let us say that GG1 is equal to BB1. So this is also equal to BB1 upon GML, and we are going to work on this principle. Trim change upon LBP is equal to BB1 upon GML. It is for this reason that I need to find out what is the KB of the vessel, because from KB, like from KB I will get KML, KB plus BML is equal to KML, and KML minus KG is GML, which I am going to use in this formula. So there is a right angle triangle that is formed here, right? And there is a right angle triangle that is formed longitudinally, where we say one side is LBP, one side is trim change. Here one side is GG1 and other side is GML. In this particular special case, as you see that the damage is vertically uniform, in only this particular case where there is no tank top, there is no intermediate separation, like the damage you can see from top to bottom till the final water line is uniform. In this particular situation, we can say that BB1 is equal to FF1. You can see the way the water plane area is affected here. Similarly, the buoyancy is affected of this compartment. So shift of center of flotation is equal to, so I can say that originally B was here and now the B1 might be somewhere here, but the longitudinal shift of BB1 is equal to longitudinal shift of FF1, right? Now, how to find out the BML? BML is residual moment of inertia about an athwartship axis passing through center of flotation divided by intact underwater volume, right? So what I do here is I will write down BB1 is equal to FF1, and that is equal to 3.387 meters. Let us try and find out what is the residual moment of inertia. So let us first find out what is the total moment of inertia regardless of damage. Total moment of inertia about athwartship axis through F, not F1. F is the original position, regardless of damage. So this should be equal to 20 into 100 cube upon 12. But if I want the total moment of inertia about athwartship axis but passing through F1, I would say 20 into 100 cube upon 12 plus AD square, that is 2000 into 3.387 square, right? So this is going to be a big figure, right? I will call it 1. But in any case, let us find out how much is this figure. 100 into 100 into 100 into 20 equals, divide by 12 equals plus in the bracket 2000 into 3.387 into 3.387 bracket closes. I get a figure 1689. Now talking about the lost moment of inertia about an athwartship axis passing through F1, that is the new center of flotation. Let us first find out where the damage has occurred. What is the lost moment of inertia about the own axis? So it is, the breadth is 20, so 20 into 10 cube divided by 12. But what is the loss about a remote axis? So that is area into d square. Now from here to here the distance is 45. So from here to here the distance is 48.387. 48.387 square. But because it is loss, I will need to multiply the entire thing by the permeability. Let's look at it. 20 into gives me 329,448.9143. I will subtract this 329,448.9143. This I will subtract from the total moment of inertia. Let's see, minus 1389610.205 gives me 1360161. Gives me 1360161.29. Divide by intact underwater volume, so that is 100 into 20 into 5. 136.016. So this is the BM longitudinal vertical distance from B to longitudinal meta center. Sometimes the candidate is puzzled as to how it can be more than 100 meters. This is not measured longitudinally. It is measured vertically. So the vertical distance from center of buoyancy to longitudinal meta center is 136.016 meters. I tend to tell the boys that linear dimensions you take 3 digits of decimal, but when you are talking about the moment of inertia, you don't actually worry about the decimal at all. So you can simply not worry about the decimal. Now, as I said before, the trim change upon LBP is equal to BB1 upon GML. Now we have found KB1 as 2.688 and BML as 136.016 meters. So the total is, so KML is equal to 2.688 plus 136.016. That is 138.704. 138.704. So what is GML? I must subtract kg from this. So the kg of the ship was 5.2. So I minus 5.2. I get 133.504. 133.504. Now trim change should be equal to LBP, that is 100, into BB1, that is 3.387, divided by GML, that is 133.504. So 3.387 into 100 equals, divided by 133.504, gives me 2.537. 2.537. Now this is the trim change. Can we find out the final fore and aft draft? So this is the total trim change by a standard formula. TRA should be equal to TRC into LCF upon LBP. Now what is TRA? TRA is not trim aft. TRA is the component of aft draft change because of trim change alone, or TRA is the change of draft aft purely because of the trim change, not because of the bodily sinkage. So TRA will be equal to 2.537 into LCF. Now this is forward end and this is aft end. Damage has occurred forward, right? And center of flotation has shifted aft. So LCF is reduced. So LCF will be 50 minus 3.387, and that gives me 46.613. 46.613 divided by LBP, that is 100. So 46.613 into 2.537 equals divided by 100 gives me 1.182 or 1.183 TRA, and TRF should be TRC minus TRA. So if I subtract it from TRC, TRC is 2.537. This gives me 1.354. 1.354. So the final calculations will be like this. Initial drafts forward and aft is 5.000, 5.000, and then there is bodily sinkage, and what is the bodily sinkage? 0.376, 0.376, that will be plus, and then there is damage forward. If the damage is forward, it means that the forward draft will increase, so TRF should be plus. So TRF is 1.354, and because it is plus, this has to be minus, so this will be 1.183. So let us see what are the final drafts. So it is 5 plus 0.376 plus 1.354. The total is 6.730. And let us see what is the aft draft. That is 5.376 minus 1.183 gives me 4.193. So forward drafts and aft drafts. You can see the vessel is trimmed by head because the damage is forward. So this is the method of finding out the fore and aft draft after a damage that is categorized. This kind of question is categorized under end compartment bilging. So we have done bilging of an end compartment which had homogeneous cargo.